Welcome to second lecture of this stoichiometry. In previous lecture, we discussed atomic weight, we discussed molecular formula, we discussed sort of cation, anion, radical group, then gram molecular weight, and then we discussed something how to determine molecules in given substance. So for that purpose, we have taken simple example that is of calcium carbonate. Now we are going to discuss some of the topic related with finding out number of molecule, finding out number of atom, like that. So those of you they are not able to observe stoichiometry lecture number 1, they should first observe that lecture and then come to observe this second lecture, because otherwise if base is not there, then from henceforth whatever I am going to discuss you are not able to understand at all. So first that base should be there and then we can proceed. So next sum I will give you here to solve. 1 liter water is there with you. Its temperature is 4 degrees Celsius and we have to find out number of molecules present in that 1 liter water at 4 degrees Celsius. I am revising the sum. We have to find out number of molecules present in 1 liter water, but temperature of that water is 4 degrees Celsius. Can we find out number of molecules? Answer, yes. Let us start one by one. So first part, that is why temperature is mentioned, because here definition of one of widely used unit, but it is not SI unit is there, that is 1 liter. Actually you are aware SI unit of volume is meter cube, decimeter cube, centimeter cube, millimeter cube, like that it should be in terms of millimeter, centimeter, decimeter, meter, cube. Anyway, but here worldwide we are observing liter as important unit in terms of measuring liquids. So definition of 1 liter, that is volume occupied by 1 kilogram water at its maximum density. You are aware water is having anomalous behavior. Density of water is maximum at 4 degrees Celsius, and therefore here volume occupied by 1 liter water at 4 degrees Celsius. That volume is volume occupied by 1 kilogram water at 4 degrees Celsius is considered as 1 liter. So it's very clear from this definition that you have provided it 1 liter water having temperature of 4 degrees Celsius. That means the mass of that water is 1 kilogram. That is 10 raised to 3 gram. Clear? So first data I will write here, that is W, that is equal to 1 kilogram or rather 1000 gram. Now molecular weight of water we are aware as formula is H2O. Its molecular weight is 2 plus 16, that is 18. Now third thing we have to do, that is N. What is N? N is number of moles. How to find out number of mole? So number of mole equal to W, that is given weight upon molecular weight of substance. So it's 1000 upon 18. You are aware of table of 18, so I can straightway go this way. 18 ones are 18 fives are 18 fives are 90. Carry forward 10. Again 100, so 55. Again carry forward 5. And like that you can go recurring 555. So I must round up here 5 at 6. Keep in mind here rule is there. While teaching only or while solving the problem only I will teach that rule how to round up. Let us take certain figures to round up. Say for example 6.667. Second figure 6.665. Third figure 6.654. 655. Fourth figure 6, 6, 4. How we are going to round up till 2 decimal. So here, as I have to round up last digit. So we have to check last digit is greater than 5 or less than 5. As this digit is greater than 5, I have to add 1 to the previous digit. So this can be rounded up as 6.6 and 7 because the last digit is greater than 5. So I have added 1 to here and answer is 6.67. Now suppose I have to round up to 1 decimal only, then obviously last digit is greater than 5. So I will add here and this answer will be 6.7. So I may write here also this I can round as 6.7 for 1 point we can go. Now here the last digit is 5. Now observe both the cases here and here. Last digit is 5. If last digit is 5, then we have to check previous number. If previous number is even number, keep it as it is. So this I can round up at 6.66. Now for 1 decimal, so this number is obviously greater than 5. So I have to add 1 here. So this will be again 6.7. Now here also end digit is 5, but previous number is odd. If previous number is odd, then we have to add 1. If previous number is even, keep it as it is. This will be only if last digit is 5. Then obviously this answer is 6.6 and I will add here, so 6. And again this will be same as 6.7. The last thing, last digit is greater than, less than 5. It is not equal to 5, not greater than 5. It's less than 5. So keep previous digit, whether it is odd or even, as it is. No change in the previous digit. So this way, and this can be also round up as 6.7. So these are the rules we are using to round up the figure. You can take it down for example. So according to this, this is 5.5555. N number of times you have to write 5. So I will round up and say it is 6 because last digit is 5. We have to add 1 digit to to the previous digit. And this way we have written here N, that is equal to 55.56. Now, what is the solution? 1 mole of any substance corresponds to 6.022 into 10 raised to 23 number of molecules. Therefore, 55.56 mole, because we have calculated number of mole, corresponds to what? And then this divided by this multiplied by this. So answer is 6.022 into 10 to the power of 23 divided by 1, obviously multiplied by 55.56. So we are getting answer, that is the multiplication of these two figures and to the multiplier of 10 raised to 23. So I hope you are able to do this calculation. This is the multiplication you can do at yourself, or else I have to show here. I will show. I will write 55.56 multiplied by 6.022. So school days method only we are going to apply. So forget of decimal and carry out calculation first. So 2 6s are 12, carry forward 1, 2 5s are 10 plus 1, 11, carry forward 1, 2 5s are 10 plus 1, 11, carry forward 1, again same, write it down as it is. Forget of decimal while calculating. Now this second 2 I have to multiply, so I will put 0 here and then multiply, but multiplication will be same. As we are aware that same figure. Now I have to put 2 zeros. No doubt I have to multiply by 0 only here, but still I should not forget to put 2 zeros over here and then multiply by 0. So everything is 0. But I will keep digit as it is. and now 6. So I have to put here 3 zeros and now multiply. 6 6 are 36, carry forward 3, 6 5 are 30 plus 3 33, carry forward 3, again same 33, carry forward 3 and 33. 2 3 2 2 plus 6 8 5 4 3 3. And what is the rule? Decimal after summer. So here after 3 places, here after 2 places. So decimal should be given after 5 places. So from here 1 2 3 4 5. So our answer, I will write here 334.58232. This is just I have shown multiplication of 6.022 into 55.56 multiplied by 10 to the power of 23. These many number of molecules are present in 1 liter water at 4 degree Celsius. Clear idea? So this is something we are talking about, say, calculating number of molecule. Now after this you have to try one more sum at your end. Now you have to solve one more sum. Now this time I will recommend you that first you listen to the sum, then solve yourself by pausing this video, and then verify that whatever you are performing that is correct or not. So a simple sum I am giving you again. Suppose you are having 11,100 kilogram, revising, 11,100 kilogram calcium chloride powder, pure calcium chloride, 100% pure. What is the number of molecules present in that calcium chloride powder? 11,100 kilogram of calcium chloride. First try yourself, then I will try. I hope you might have solved the sum. It's very easy, but if not, then let us discuss in depth. So first thing, W. So it is 11,100 kilogram. Just verify the figure, it is 11,100 kilogram. So I have to convert it into gram. So 11100 and put 3 zeros, gram. So this way we are converting out into gram. Now next figure, MW. You are aware, calcium chloride. Should I write formula? CaCl2. You are aware it is 35.5. 35.5 to the 71. 71 plus 40, 111. So molecular weight is 111. Next, find out number of moles. So 1110000, 5 zeros. That is W upon MW. MW is 111. This is 1 za, and then put 1 2 3 4 5 zeros. So this is number of moles. And next, number of molecules. So simple, we can find out number of molecules. When I will say molecules, according to modern principle, atoms, they are also considered as monoatomic molecule. So when I consider molecule, it may be atom, it may be molecule. So number of molecules, that is equal to n into 6.022 into 10 to the power of 23. So according to previous sum, we were dividing this by 1. So here also it is implemented. Any figure if writing this way, then implemented condition is divided by 1. So here it is 1, 2, 3, 4, 5. So can I write this as 10 raised to 5? Go to our simple arithmetics lecture, there we have explained. So it's 10 raised to 5 into 6.022 into 10 raised to 23. So we can end out by 6.022 into 10 to the power of 23. So when base is same, we have to add up 2. So 23 plus 5, 28. So I will sum up here only as this. So number of molecule equal to, this is the final answer. So check out this way, that are you able to solve this type of sums? They are based in stoichiometry. Now I hope you are having proper knowledge about number of say atomic number, atomic mass number, everything. So we are going little bit higher level, not very high, but little bit higher level. For that purpose, take this next term. Calculate number of electrons present in 10 kilogram of sodium chloride. I am revising. Calculate number of electrons present in 10 kilogram sodium chloride. Obviously implemented condition is pure sample. So try to solve yourself first. Pause this video, try to solve. If you are not able to solve, I will be there to solve. First, we have to find out number of molecules in 10 kilogram sodium chloride. So you are aware of the formula, that is NaCl. So W is given as 10 kg, but you are aware that 10, you have to put 3 zeros, gram. So 10,000 gram. MW, now this will be in fraction because 23 and 35.5. So it will be 58.5. So molecular weight 58.5, and then N, that will be equal to 10,000 divided by 58.5. Apparently, you may say the calculation is difficult. Yeah, little bit difficult calculations, but we are trying to make it easy. I have to remove decimal and put here 10 raised to minus 1. If I am taking 10 raised to minus 1 to numerator, it will be 10 raised to 1. And then I can implement one more 0 as multiplier of 10. So I have removed decimal by putting one more 0 over here. Now this is all whole number, and I can reduce, go step by step. 5 ones are, 5 ones are, carry forward 3, 5, 7. That's why I say it seems difficult, because this type of odd figure is there. Whereas divided by 5, so 5 2s are 0, 0, 0, 0. And now I don't have any alternative as we have carried out this. So we have to go by traditional method. So till 3 I should put 0. So here 0, 0. Now 1s are, so 1, 1, 7, 3, carry forward 1, so 10 minus 2, 8, carry forward 1, 0. So it is 83. Then I have to take 0 again. Now it's obvious that this figure is close to 100. So if I am saying 1178 za, then figure will be greater than 8. So I have to put here 7 za. So I will write here 7, 7, 7, 49, carry forward 1, 4, 7 1 za, that is 11, carry forward 1, and then 7 1 za, and carry forward 1, so 8. So figure is this. So ultimately carry forward 1, 1 and 0. Now I have to take one more 0 which is already available, but I can't divide because this is greater than this. So that will be the end. Now I have to put decimal and take one more 0. Now it's obvious that it is greater than, if I am multiplying by 10, then obviously this will be very huge figure. So I have to try with 9. 9 7s are 63. Carry forward 6. 9 1s are 9 plus 6, 15. Carry forward 1. 9 1s are 9 plus 1, 10. So we are getting, this is the figure. Now, just I will carry out calculation, but I hope this is the sufficient. Okay. So, because again we have to take 0, then again huge figure will be there. So rather than that, we can round up at this way. So n, that is 170.9. And now next job is easy. Find out number of molecules. So number of molecules, that is equal to number of mole into 6.022 into 10 to the power of 23. So I will write here that 170.9 into 6.022 into 10 to the power of 23. This is the number of molecule. Now you have to check again what is the sum. We have to find out number of electrons in this amount of sodium chloride. Sodium is having atomic number 11. As sodium is having atomic number 11, one sodium atom will contain 11 electrons. Chlorine is having atomic number 17, so chlorine will contain 17 electrons. So net NaCl will contain 28 electrons. One molecule of NaCl contains 28 electrons. So this is the number of molecule. Contain how much electron? So we have to multiply this by whatever the figure we have to calculate, that is multiplied by 28. And now carry out calculation. So in previous sum we have discussed the calculation same way. Carry out the multiplication of these two first. And after multiplying these two, if you have by hearted 28 table, all right, otherwise proceed same way and carry out calculation. That is the number of electrons. Obviously multiplier will be 10 to the power of 23 will be multiplied. That is the number of electrons present in 10 kilogram sodium chloride. So we achieved one more level of calculation. Now henceforth I will not focus much on the calculation, but you have to focus because you have to make practice. We have to solve steadily, step by step difficulty level sum. So we will switch over to one more difficulty level. So first take it down, complete the sum. I have not completed here, so complete the sum, and then we will switch over to next sum. Little bit complicated, not 100%, but little bit complicated. A particular sample of rock salt. You are aware of rock salt. Its great crystals are there. Usually we are getting it under the soil. So crystallization process is perfect in that such rock salt, and therefore rock salt usually we are getting 99.99% pure sodium chloride. So particular sample of rock salt contains 99.9% sodium chloride. Then out of remaining 0.1%, half is magnesium chloride and half is calcium chloride. Alright, I am revising. A particular sample of rock salt contains 99.9% sodium chloride. Whatever remaining 0.1% of that, half is calcium chloride and half is magnesium chloride. If we have 10 kilogram of such rock salt sample, calculate total number of protons present in that sample. Calculate total number of protons present in that sample. So start yourself first. First you have to make plan how you are going to solve. After making plan, try to solve that. I will not solve, you have to solve. So first make plan. I will just guide you how to make plan. The first thing that we have mixtures. Till here, what we solved, that is only pure sample. But now we are going to analyze a mixture. So first we have to find out 99.9% of 10 kg. Clear? When we are saying 99.9% of, when this type of is there, we have to consider multiply by 100. So we have to find out the 99.9% of sodium chloride, that weight you are going to calculate of that 10 kg. Then remaining 0.1% half. So that weight of magnesium chloride and calcium chloride you have to find out. Then find out molecular weight of sodium chloride, molecular weight of calcium chloride, molecular weight of magnesium chloride. Then find out N for each and every case. So N for calcium chloride, N for magnesium chloride, N for sodium chloride. Then you have to find out number of molecules. Then sum up all number of molecule. After summing up of all number of molecule, or rather keep it as it is. Don't sum up. Then you are aware how to calculate proton, because atomic number is number of electrons or number of proton. So from that basis, just as we have calculated here the number of electrons. Now here I am saying number of electron, but number of proton is also same. 11 protons and 17 protons, total 28 proton in sodium chloride. So one answer is there. Now same way calculate for magnesium chloride. Atomic number of magnesium is 12. Atomic number of calcium is 20. So you can calculate and then add up all electrons, all protons together. So pause this video, try to solve yourself, then observe this video to check whether I am solving correctly or not. Thanks. I hope you have solved it. If not, check out. If yes, then check out I am solving correctly or not. So first thing, let us calculate separately. So I hope you are able to read this small handwriting, because the thing is that we have to calculate too much of thing, and I don't want to clear the board in between. So little bit smaller handwriting I am using. So NaCl, which is 99.9%. So out of 10 kg, so weight is 10 kg. That means I have to consider it as 10,000 gram. To that we have to carry out 99%. 99.9%. Cent means century here. So per 100 it is 99.9. So I will remove 10, 10, 10, 10. So 99.9 multiplied by 100. So decimal will be shifted one place and second place. So answer is 9990 and 0.0, but I will keep it as it is. So this is the it must be in terms of gram, because we have already considered this in terms of gram. So I will consider this gram. Don't get confused with 9 and G. I am writing G, sort of small g is written. Many times it happens that in school days we are writing out gram as GM. But according to SI unit, it is not GM, it is only G. Because when we are saying kilogram, we are not writing kgm, we are writing kg. So this is the weight of this sodium chloride. Then we can calculate first sodium chloride only. Step by step we are going to solve. So now we are going to, we are aware of molecular weight of sodium chloride, that is 58.5. So 23.5, 23 of sodium, 35.5 gram of chlorine. So it's 58.5. And now we have to find out N. So N1, I will mention here N1 for sodium chloride. So it is 9990 divided by 58.5. But you are aware, according to our previous calculation, we can write down simply one more zero above, and I will write here 58.5 instead of that 585. So decimal is removed. So 5 ones are 5 ones are 5 sevens are. Same figure, odd is there. Now 5 ones are carry forward 4, 5 nines are carry forward 4, 5 nines are carry forward 4, 5 eights are nothing is carry forward. So number of moles, that will be, I have to calculate 19980 and here 117. Now it's 117, so 280. Again take 8, same previous calculation, I can go here by 7. Now after 8 I have to take 0, but we are aware we can't divide, so keep it 0 as it is. Then put decimal and take one more 0. Now we can go here as again 7, because you are aware that 7s are, we are getting 819. So directly I will go here 1 8 0. Again I will take 0, but now it is not 7s, it is 6. And don't need to calculate further. So I will say that number of mole equal to 810, number of mole equal to 170.76. This is, we have finished number of mole calculation for sodium chloride. I will make box over here. But let me continue that we have to find out number of molecules. So number of molecule will be multiply by 6.022 into 10 to the power of 23, and finally number of proton. So I will write once again, it's 170.76 into number of proton. We are aware 28 number of protons are there, 11 proton from sodium and 17 proton from chlorine. So multiplied by 28, and this 6.022 into 10 to the power of 23 will be considered. So this is the number of protons. I will write here intentionally proton from sodium chloride. So this is number of proton from sodium chloride. Now let us start calculation for magnesium chloride. Now formula of magnesium chloride is MgCl2. So molecular weight, magnesium is having atomic weight 24. So Cl2, that is 35.5 into 2, 71. 71 plus 24, that will be 95. So this way we can calculate molecular weight. Now we are going to find out percent. So it is not 0.1. say it is, suppose I am adding 0.1, then it will be 100. 0.1 divided by 2, that is 0.05. So percentage of magnesium percentage of magnesium chloride is 0.05% of obviously 10,000. So what is the weight of magnesium chloride? That is 10,000 multiplied by 0.05 divided by 100. So same calculation. See here what we have performed, 99% multiplied by 10,000. So 10, 10, 10, 10. Now remaining point is shifted and weight is 5 gram. So we got weight of magnesium chloride as 5 gram. We are aware magnesium chloride molecular weight as 95. So what is N? N equal to W upon MW. So it is 5 upon 95. So I will keep this as it is. Okay, because multiply this by 6.022 into 10 to the power of 23. This will give me number of molecules of magnesium chloride and how many electrons are there in magnesium chloride. So obvious answer, its atomic number is 12, whereas this atomic number is 70, but it is MgCl2. So 17 2s are 34, 34 plus 12, that is 46. So 46 into 5 upon 95 multiplied by 6.022 into power of 23. This is number of electrons, number of protons from magnesium chloride. Now third part I have to check, that is calcium chloride. So obvious thing, weight of calcium chloride should be same because it is 0.5%, 0.05%. So weight I should not calculate now, it is just 5 gram. Now MW of calcium chloride, we are aware it is 111 gram from previous sum only. And now what I have to calculate, that is number of moles. So N, that will be equal to W upon MW, that is 5 upon 111. Now number of molecules, that is 5 upon 111 into 6.022 into 10 to the power of 23 and multiply by a single molecule of calcium chloride. Now let us calculate single molecule of calcium chloride. So here atomic number is 20. So 20 electrons, and you are aware chlorine is having 17. 17 2s are 34. 34 plus 20, 54. So multiply this figure by 54. You will get number of protons in calcium. So by looking at these boxes, you can check out number of protons present in sodium chloride, that is solved in red color, then in blue green color or green blue color, whatever that, there we will get number of protons from magnesium chloride, and in blue color with only red multiplier you will get number of protons from calcium chloride. Now thing is that you have to add this thing. So I am just showing how to add. So let us assume this figure as X, whatever you are going to calculate. Let us assume this figure as Y. I am not considering multiplier. Multiplier is kept separate only. So here also multiplier is kept separate, here also multiplier is kept separate, only this calculation is Y. And same way this calculation, that is Z. So what you have to do? You have to add X plus Y plus Z. Because for everything multiplier is common. And so whatever the answer, multiply by 6.022 into number 23. So these are protons present in 10 kilogram of rock salt, which is 99.9% pure. But by giving knowledge of impurity, we can able to calculate total number of protons present in this. So I hope these things you may find it easy. Keep in mind, this is all fundamental level, but we are gradually going up and up and up.